Just like we can graph our parabolas in vertex form, we can also graph in standard form. And the process is very, very similar. I guess our main difference, and really the only difference, is how we get that first point on our parabola, how we get that vertex, which now we know how to do in standard form. So I guess our first process is to find our vertex, just like when we had vertex form. And that's what I will do over here. Find the vertex first. X coordinate of my vertex is negative b, which b is my coefficient in front of the x. So negative b over 2a is negative 2, which gives me negative 2 over negative 4. We get a fraction here. That's okay though. So the x coordinate of my vertex is 1/2. Alright, we can work with this. That's alright. Let's plug this into my equation to get the y coordinate of my vertex. Y equals negative 2 times 1/2 squared plus 2 times 1/2 minus 5. Alright, well 1/2 squared. Don't forget though, 1/2 squared means 1/2 times 1/2. And if I come over here, if I take 1/2 times 1/2 to multiply my fractions, we multiply our numerators, we multiply the denominators, that gives me 1/4. So negative 2 times 1/4, well 2 times 1/2 is just 1, minus 5. Negative 2 times 1/4 is going to be negative 1/2. Plus 1 minus 5 is negative 4. Alright, so you're probably thinking negative 4.5. We like our answer written as an improper fraction. That's just kind of how math is done, I guess, kind of like math's version of grammar, I guess. Improper fractions are better. And if I wanted to write this as an improper fraction, I need a common denominator here. So 4 is 4 over 1, which is 8 over 2. Negative 1/2 minus 8/2 is negative 9/2. So my vertex, after all of this work, is positive 1/2, negative 9/2. Alright, let's plot that vertex. (1/2), negative 9/2. Is right here. Okay, now I'm going to draw on my axis of symmetry, and I will use a different color here. My axis of symmetry is going through at x equals 1/2. Just like with our vertex form, now that we know our vertex, we know our parabola is the same on both sides, we can plug in some other values for x that are pretty close to my vertex. So I guess 0 would probably be a good value to plug in, and that works out really, really nicely. Plug 0 into my equation. I get y equals negative 2 times 0 squared plus 2 times 0 minus 5. Well, negative 2 times 0 squared, 0 squared 0 times negative 2 is 0, plus 0, I get negative 5. 0, negative 5 is on my parabola. And if 0, negative 5 is on my parabola, same right over here on the other side of my axis of symmetry. Okay, real quick, I'm going to point out this negative 5 is my y-intercept. It's what I get when I plug 0 into my equation. And look right here. that was my C value in standard form. So I mentioned at the end of that very first video you saw that the C value is also our y-intercept. Now we're actually seeing it. Let's repeat our process one more time with one other x value so we can get another point on our graph. Okay, we plugged in 0, which is the same thing as if we'd plugged in 1. Let's plug in 2. You could plug in -1, but for the sake of keeping positive numbers, I'm going to use 2 in my equation. Plug 2 in. Y equals -2 times 2 squared plus 2 times 2 minus 5. 2 squared is 4. 4 times -2 is -8. Plus 2 times 2 is 4. Minus 5. -8 plus 4 is -4. Minus 5 is -9. So 2, -9 is on my parabola. And I think I'm going to have to extend this a little bit. Not too bad, though. But now we can connect our dots. We have our vertex, 2 points on either side. And this one, we had a little bit of messiness coming from our fraction there, but fractions are our friends. They're really not the end of the world. And we get our graph the same way.